Hi friends, my dear students. 12th Physics second volume 7.4 X-rays. The very important heading, all 1 marks, 3 marks, 2 marks are possible to ask in the theoretical aspects. So keenly observe all the concepts clearly, then only you are able to answer for all questions. Okay. Now, as per the theory of quantum theory of radiation, we already explained the photoelectric effect. Let us assume a metal, if instant light rays like photon, an energetic particle which are hitting the surface of the metal, then it will limit the electrons. This is a process of photoelectric effect. Now, the total energy of the electron which are hitting the surface are completely transferred to the emitted electrons. That means the energy of the electron are completely transferred to the electron. Then these electrons are capable to move with the energetic particle in the same energy of the photon. That's the thing we already explained by means of photoelectric effect. Now, the 2 point occurs here. The first one is if the energy of photon are transferred to the energy of an electron. This is possible in vice versa or in reciprocal. Is it possible to transfer the energy of an electron to the energy of photons? Is it possible? That's the main theme that we have to explain today here. When the instant ray energy or instant ray light rays consists of photons as per quantum theory, each and every photons which have the maximum energy are completely transferred to the emitted electron, so that electron are emitted with highest energy level. Now we are now the question arises here, energy of the photon are transferred to the energy of an electron. Is it possible to, in the reverse way? That means the energy of an electron are transferred to the energy of the photon. That is the question mark. Is it possible or not? That's why in 1895, Mr. Ranjan, who gave his valuable theory, and this is possible, when we are producing the X-rays. When higher velocity of electron beam, whenever hit the surface of any metal, then X-rays are produced. Here, higher velocity of electron ray or beam hit the surface of the metal, then X-rays are produced. This X-rays energy is equal to the energy of an electron, so that the question mark may be cleared out. Question mark may be clearly explained by means of this experiment. Now, what are the properties and what are the important points that we are going to deal today now? That's a very important. First, here the when you consider any metal like in the form of as shown in the figure, if the electron rays hitting on the surface of the metal of any tungsten or molybdenum or any other thing, then the X-rays are produced. Here, the penetrating power of this X-rays, the penetrating power of the X-rays, which will depend on the which will depend on penetrating power of the X-rays, which will depend on the velocity of an electron. Velocity of an electron. That's a very important concept. One by one I have to clearly explain. You have to keenly observe all the points. As per in the textbook, I am not ready to explain for you, but each and every point are separately I have to give for you to easy understanding manner. The first point, the electromagnetic radiation that are light rays or photons, whenever hitting or the surface of the anode, here the X-rays are produced. And what are the properties that X-rays are possessed? That is very important. The X-rays wavelength are very less. X-rays wavelength are very less, as well as it has the value of 0.1 Armstrong to 10 Armstrong. That is a very important concept. First point. Second point, it travel with velocity of light rays in straight line manner. It travel, X-rays or travel in the media with velocity equal to the light rays and in the straight line form. That is the second very important property. That means the total energy of electron are transferred to the X-rays photon. X-rays photon. This X-rays photon is nothing but light photons energy. Light photon energy are converted into X-ray photon energy. That's a very important concept. That's why it is traveled in the second path. Okay. Third point. Third point is very important. It will not affect X-ray. When you are considering X-rays, these are called X-rays. X-ray. When you are applying, this is called positive and this is called negative. Here you are applying electric field. Then the path will not be changed. That means this X-ray which will not affected by the electric field. The same manner, if you are applying or magnetic field here in the same place in the path of the X-rays, again this X-rays path which will not be altered and it moves in the straight line manner. It shows that the X-rays path are not affected by means of either electric field or by magnetic field. It leads that there is no charge of this particle. There is no charge of this X-ray particle. That means all the particles which are emitted by the anode or tungsten or molybdenum, it is purely chargeless particle but more energetic particle. That is a very important point It will not affect either by electric field or by magnetic field. It goes straight line. It goes straight line. And fourth point, when the energy of the photon, when you consider to be an photon, the energy of the photon, X-ray photon is considered to be the frequency. If you consider the frequency of the energy of the photon or the photon frequency, which is higher but wavelength is less. Once again repeat, keenly observe, photon energy, X-ray photon frequency is high and wavelength is less, so that the energy become very high. Energy become very high. This is very important concept. When the wavelength of the X-ray photon is less, as well as the frequency is high, the energy automatically raised, so that the energy of the X-ray photon, which will be the highest value. That is the fourth important point. Fifth important point, when you are utilizing ordinary light rays, it will stop by even a piece of paper, or cardboard or wood, anything else, or aluminium, thin sheet, anything else. Whereas if you are considering X-ray, it will not stop this X-ray, but apart from that, it penetrating this thin foil or piece of paper or wooden paper or any small metals like that. That's why the penetrating power is higher than the penetrating power of light rays. That's the fifth important point. These are the important points that we are discussed about the characteristics of X-rays or properties of X-rays. These are very, very important. All are important points. It may be asked in 1 mark, or sometimes it may be asked in 2 marks, or combinedly they may be asked in 3 mark also. So try to understand this concept clearly. I hope you may understand. Can I rubbing it or now the next important point. When you consider X-ray quality of the X-ray, which will depend on what is meant by penetrating power, or in Tamil, ஊடுருவுதல்னு சொல்றோம் தமிழ்ல, ஒரு பொருளை ஊடுருவி போறது. In English, it is called penetrating power of X-ray depends on this. The X-ray's quality is dependent on the penetrating power. Whereas this penetrating power depends on the velocity of the electron. This is a chain process. X-ray quality is dependent on penetrating power of X-rays. The penetrating power which will depend on the instant ray velocity of the electron velocity. This is a very, very important concept you have to clear. Then in this case, if higher velocity of electron whenever hit the target, then there is emitted X-rays are most powerful energy and have more penetrating power. More penetrating power. That's a very important concept. More penetrating power. That's the concept that I want to explain to you. The next point, this is called first point. Second point, when the X-ray intensity, which will depend on are directly proportional to number of electrons hitting the target. If more number of electrons hitting the metals, more number of electrons hitting the target, then there is more intense beam. There is more intensive beam. That is called intensity, which will be increased. If you are decreasing the number of electrons, then the outcoming intensity of the X-rays which will be decreased. From this point, we conclude that the penetrating power as well as the intensity of the X-rays penetrating power and X-rays intensity, which will be controlled only by means of either you are decreasing the velocity or reducing the number of electrons. That's the thing that we have to understand. If you are reducing the velocity very just less than the prior one, then the penetrating power also decreased. If you are reducing the number of electrons less, then the intensity which will become less. This may be utilized in the medical purposes. For example, if you are taking abdominal X-ray, then you send a minimum intensity of X-rays. That's enough to take X-ray. That's why we must control the outcoming intensity of the X-rays by reducing the number of electrons. Or in other words, if you want to reduce the penetrating power of X-ray, then you can reduce the velocity of the hitting electron. Then you can reduce the penetrating power of the X-rays. This is a two concept is the most important concept that are mainly used in the medical uses and in future purposes for all aspects that we are going to see one by one. Then I hope you may understand clearly. That's why I want to give one by one the properties and what are the nature of the X-rays quality. This is called intensity. Now, next, how can we produce the X-rays, and what are the apparatus that we are utilized to produce the X-rays, and how can we produce the X-rays, and what are the outcoming X-rays produce the spectra, whether it is line spectra or continuous spectra. What is the characteristics of the ordinary continuous spectra and special continuous X-ray spectra? That's the thing that we are going to see now. First, we have to explain the apparatus setup. Now we have to consider an evacuator tube as shown in the figure, like a globe, and one end is connected with the filament that is called a filament, which is filament is attached with a low tension battery, so that we are applying low voltage to the filament. the filament which will be getting heated. So what? We are allowing the low tension battery to illuminate this filament to the maximum level. Just initially it will glow like a dark yellow, and then yellow, then whitish yellow, then it will become a whiter. Like until that you have to apply the lower tension battery or applying the voltage to the filament. Here in red color it is called cathode. Cathode, it is nothing but negatively charged particle, and these two parts are called as electron gun. We already studied in the Davis and Germer experiment. What is in the electron gun? It is nothing but when we are applying the voltage to the filament, it will emit the electrons, and which are channelized by means of a discus. Disk and scattered electrons move towards anode if we are applying the higher voltage to the anode terminals made up of copper, and in front of the portion of the anode are coated with the tungsten or molybdenum, because higher energy of electron emitted, and because of the higher energy this copper anode may be melted, and completely the energy whenever hit the surface of this anode, then energy become completely transferred to be as in the form of heat, so that it may be melted. To avoid such a situation, we are embedded tungsten or molybdenum in front side of the anode, which is at an angle, because whenever hit the electron rays on the surface, then the X-rays are produced. To easy emerging of electron, we are shaping like a cross like this. That's the apparatus setup. Now, when you on the low tension battery to the filament, there may be heat evacuated, then the filament automatically emit the electrons, and these higher value of electrons move towards anode only because of accelerating potential. We are giving excess of potential to the anode terminals. That's why this anode which will pull the electron towards the anode terminals. So what? The kinetic energy of the electron which are rapidly raised and hit the surface of the tungsten or molybdenum. So what? Within the fraction of the second, there may be emission of X-rays. This is the fundamental working condition of these X-rays. How X-rays was produced. This is very important to understand how X-rays were produced. Okay. Now, what's the difference between ordinary light rays and X-rays? X-rays and ordinary light rays. This was asked in 1 mark. How can you differentiate? Ordinary light rays having more wavelength and less frequency. But if you are considering only one photon, the total energy of photon is transferred to the X-rays photons. Light photons energy are transferred to the X-ray photons. Here, X-rays, when you think about X-rays, the intensity and wavelength, how far it is. Wavelength is low, so that the frequency is high, so that the intensity also high. If you are reducing the wavelength, the frequency of the X-ray photon which will be raised, and so that the intensity of the X-ray may also increase. We already see in the property of X-rays. That's a very important concept. Now, if we are applying a basic principle and we know the value of lambda, simultaneously the intensity of the X-ray may be modified, depends on the wavelength. If you are increasing the wavelength, the intensity which will be reduced. If you are decreasing the wavelength, the intensity may be increased. If you draw a graph between wavelength in x-axis and intensity of the X-rays in the y-axis, at a particular value of accelerating potential called 50 kilovolt, then what happens here? There may be one continuous spectra shown in the figure. Here it maximum it reaches and the wavelength is said to be lesser. That's why when the wavelength is less, the energy become more. Why? Because of the intensity, because of the frequency, the energy become more. That is the basic principle that you have to understand. When the wavelength is less, nu is high and E is also high. In other words, if you are reducing 40 kilovolt accelerating potential to the anode, then what happens? The wave curvature as shown in the figure is shown in the figure, and if you draw the wavelength, it is greater than the lambda 1, lambda 2. Here lambda 1 is greater than lambda 2 is greater than lambda 1. That's why energy is reduced. If you consider reduced again 30 kilovolt, again you have to draw the wavelength lambda 3, then it may be greater than lambda 2. Or if you want to reduce 20 kilovolt, then what happens here? Lambda 1, lambda 2, lambda 4. Then what happens? Lambda 4 is greater, but energy is less. This is called or you can draw like the figure. The intensity also varied. The energy also, here the energy and intensity less comparatively lambda 3. From this analysis, we conclude that when you reduce the lambda, the intensity become more. When you increase the lambda, intensity become less and energy become, when you reduce the lambda, energy become more. When you increase the lambda, intensity and energy also less. That's a very important concept. You have to clearly understood when you draw the graph between lambda as well as the intensity of the outcoming X-rays in the discharge tube or evacuator tube. This is called discharge tube or evacuator tube for tungsten. If suppose you consider this spectra seems to be continuous spectra. X-ray spectra is nothing but a continuous spectra, not discrete, not line spectra, but it is a continuous spectra. Then we have to deal about minimum wavelength or cutoff wavelength and maximum wavelength. Next step. Now, if you want to draw a graph between tungsten and molybdenum at the kilovolt, 35 kilovolt, when you are applying The accelerating potential between anode and cathode is called 35 kilovolt. Then what we get, the red figure shows the tungsten continuous spectra. It shows that there is only, it reaches maximum, the wavelength are here. Whereas for molybdenum, instead of one maxima we get here also one maximum, and another there may be more nodes which are called K beta and K alpha. At a particular frequency wavelength, at a particular wavelength, the intensity which will become higher, because at a particular wavelength, the intensity of the outcoming X-rays for molybdenum when it was accelerated by 35 kilovolt in between the terminals of anode and cathode, then we are getting maximum peak value K alpha and K beta. In both are shows that the characteristics of the target metals are called molybdenum. It exhibits the characteristics of the molybdenum. That's a very special character. That's why this X-ray are called special characteristics X-rays. Special characteristics X-rays for molybdenum. This is a very good analysis. With the help of this diagram, we conclude. So what? You understand the concept clearly. I hope it's so. But at last, we conclude that as a classical electromagnetic theory, according to the classical electromagnetic theory, the emission of radiation from accelerating electrons, it could not explain two features established by X-ray spectra. One is the first one is, for given accelerating potential, for given constant accelerating potential, you are not changing 40 or 30 or 20.